On an earlier slide, we quoted Joule, who considered that exchanges of heat were equivalent to mechanical work. We also said that work and heat were not different forms of energy, but different modes of energy transfer. So how different are heat and work at the macroscopic level? When we think of work, we visualize pushing a load up an incline, pulling a weight using a pulley, moving electrons in a wire under the action of a difference in voltage, or compressing a gas. In all cases, we can see that mechanical, electrical, or compression works are associated with a uniform motion in the surroundings to change the energy of the system. In contrast, as was pointed out by Joule, heat causes or uses chaotic motion in the surroundings to change the energy of the system. This distinction between organized and chaotic motion of matter will acquire greater significance when we discuss the second law of thermodynamics in Chapter 2. The sign conventions we use in this class for heat and work are conventions used by all scientists in the chemical sciences. These conventions go hand in hand with the way we are going to write the first law of thermodynamics. So it is very important that you memorize them and check the signs of the calculated work and heat in light of these conventions. We say that work done by the system on the surroundings is negative, while work done by the surroundings on the system is positive. For example, the compression of a gas is obviously done by the surroundings and as such result in a positive work. As a system expands during isobaric heating or during the sublimation of a solid into a gas, the system does work on the surroundings because it is pushing the boundaries of the system further into the surroundings. Such work is by convention negative. Another way to view these sign conventions is to say that work is negative when it contributes to a decrease in the energy of the system. After all, one definition of energy is that it is a measure of a system's ability to do work. The more work a system does on the surrounding, the less energy it has at its disposal. Similarly, heat flowing from the system into the surroundings, by convention, is negative, while heat flowing from the surroundings into the system, by convention, is positive. Again, this convention is such that a positive heat contributes to an increase in the energy of the system. The advantage of the sign convention used in the chemical sciences is that heat and work are both positive when they flow from the surroundings into the system, and negative when they are transferred in the opposite direction. However, conventions are just what they are. They are simply conventions. So you should remember that physicists and engineers have chosen an opposite sign convention for the work. Obviously, they also write the first law of thermodynamics using a different sign for the work.